So if I have a function, f of x, what happens if I add a number on the inside? It moves to the left. What if wow, I'll figure this out eventually. What if I subtract the number on the inside? Moves it to the right. What if I multiply the inside by a number? So we're gonna make the x's, for instance, let's say if I make the x's 2 times as big, what's that gonna do to the graph? So let's take a graph, for instance, here. So I have these points. If I make the x's 2 times bigger, then it's going to get wider, right? My y values will remain unchanged, but my x values are going to become twice as big as they were before. Does that make sense? Okay. What if I divide the x values by 2? Then it's going to get skinnier because my x values are going to be twice as close to the y-axis as they were before. Okay. So what if I have f of x minus a number? It's going to go down. If I add a number, it's going to go up. What if I multiply f of x by 2? So I take my original graph, whatever it is, and I make so these are y values. What if I double my y values? Then this number is going to bounce up here. This number is going to go to here. This number will remain unchanged. And it's now twice as tall as it used to be. What if I divide my y values by 2? It's going to get wider, so we're going to compress the y values. Okay? What if I change the sign of my x's? Flips it across. So if all my positive x's turn into negative x's, it's going to flip across the y-axis. What if I make my y values negative? I'll take all of my positive y values and turn them into negative y values, and it rotates across the x-axis. Okay? Well, what if I have a whole bunch? Negative 2 f of x plus 1 minus 4. So we start on the inside. Left one. Well, this one first. Reflected across the x and expand the y's by 2. So stretch it vertically by 2 and then subtract 4. Okay? So we're going to be dealing with quadratic equations and absolute value equations. If you take a look at the worksheet, up at the top, it says, what is the transformation? Well, number 1, how is it going to differ from the original parent function of x squared? It's going to go up 4. So all you're doing here is describing it. Now, if you forget, graph the original and graph the transformation, and you'll be able to see how it changed. Okay, if you go down to number 5, well, let's do 6. How is number 6 going to look in comparison to the original x squared? Not up 4, left 4, down 3. So we're going to go over 4 and down 3. Did the shape change? No. Did it reflect at all? No. So it's going to look like this. The vertex is the coordinate of either the minimum or the maximum, depending on which direction it faces. What is the vertex? Negative 4, negative 3. Okay, what is the domain of this function? All real numbers. What is the range of this function? It goes as low as negative 3 and as high as infinity. Is negative 3 part of the range? Yes, because it actually is the vertex, like that. And then it also says identify the axis of symmetry. There is a line that divides this parabola into two equal pieces, which is called a line of symmetry. What is the equation of the line of symmetry? It's x equals, so the axis of symmetry is x equals -4. That line is every point where it's -4y, where every x value is -4 and every other y value would be there. Now, some of the y's don't actually show up, so it's kind of restricted to the range, but the equation is x equals -4. That is the vertical line that divides this parabola in half. Okay? And then if you turn 2 pages ahead, you're going to do the exact same thing with absolute values. So 10 through 15, you're going to look at it and say, what transformation is happening here? So number 10, what's going on? Flipping across, we're changing the y values, which means we flip across the x-axis, right? Well, it's the difference between negative f of x and f of negative x. In this case, we plug in our x's into f, which turns them into y values, and then we change their signs. In this one, we change the signs before we turn them into y values. So which one is this? Do we change it before we plug it into the function or after we plug it into the function? After. So the x's get turned into y's, and then the signs get changed. And if you change the y values, that flips across the x. And then down 2. And I want to show you something. Let's take the original absolute value. Let's flip it across the y-axis. And let's bring it, or sorry, x-axis. And then let's bring it down 2. Okay? So that would be, this would be my end result. Does it change things if I do them out of order? Well, let's look. So let's take the original function, take it down 2 units. Now what happens when I flip that across the x-axis? So it's going to look like this. So the order is very important. Now, if all you're doing is moving left and right and up and down, you can get away with it. But when you start reflecting, the order you reflect is important. You have to do it in the correct order. So which one is it? Which is it? Is this the end result, or is this the end result? The one on the left is, how do we know? We follow order of operations. So it says we take our x's, we absolute value the x's, and then we change the signs, and then we subtract 2. And that tells you the order that the transformations need to happen. And it really only matters if you're reflecting. If you're not reflecting, then the order is not as important. Well, that's not true. If you scale the x's and scale the y's, that would create problems if you did them in the wrong order. Okay. Any questions about that? It should be pretty simple. I think you'll get done in plenty of time. Good luck.